All right, question 4 says Linda is using the garden hose to wash her car. The path of the water can be modeled by the quadratic function as defined by V of H equals blah, 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 where H is the horizontal distance in feet from where the water comes out of the end of the hose, and V of H, the output, is the vertical height in feet of the water above the ground. By the way, Linda is standing 3 feet from her car. All right, so just to like help us picture this really quick, I'm definitely not an artist, so let's not make fun here, but imagine you're washing your car. So here we go. This is going to be my car. Yay, how's that? Beautiful. Okay, there's my car. And then here's Linda. She's standing 3 feet away from the car, 3 feet. Here's Linda. Hi, Linda. And she's holding a water hose. And so as she's holding the water hose, and if it's on, the water itself is going to come out of the water hose and hopefully land on her car, right? Hopefully, we want that water to land on the car. And so the variable h stands for the horizontal distance of that water path, right? That's what H is going to stand for. And then V of H is the vertical height off the ground. So V of H is the height of that water off the ground, whereas H is the horizontal distance of the water from where it comes out essentially of like her hand, right? So from here to wherever, that's what H represents. Okay, so now that you've imagined at least a little bit what this stands for, or what this is trying to represent, let's take a look at part A. So part A says determine the vertical intercept and explain its meaning. All right, well, good news. We've got a standard form quadratic. So you've got your A, B, and C parameter. And in standard form, the C value is always your vertical intercept. You could plug in 0 for the input, and you would see for yourself that yes, you get 3.78. So vertical intercept is 0, comma 3.78. And what does that stand for? Well, again, you've got that horizontal distance from the hose where she's holding it and the vertical height of the water path above the ground. So what these mean is that the water has an initial height of 3.78 feet. Actually, and we don't even need to contextualize the 0, I feel like, because I already said initial. Because what does the 0 mean? It just means that there's no horizontal distance associated to the water at that moment, right? So it's like this dot right here would be the vertical intercept. So the horizontal distance is none because it's right when it comes out of the spout. I guess we could say that. We could say when first coming out of the spout. Yeah, maybe we'll go with that. Because again, it's essentially this dot right here. There is no horizontal distance associated. It's right when the water leaves the hose. But since she's holding it in her hand, it does have an initial height of 3.78 feet off the ground. So yeah, that works, I think. The water has an initial height of 3.78 feet when first coming out of the spout. That'll do. Okay, part B. Determine the horizontal intercepts and explain their meaning. Okay, so when you're working with standard form, the horizontal intercepts are not easily identifiable. So we're going to plop this puppy in Desmos to see what the horizontal intercepts are. So negative 0.587 x squared plus 1.9 x plus 3.78. All right. So here's that water path, so to speak, and the horizontal intercepts would be there and there. Okay, so as far as just mentioning them, what are they? They are, whoa, yep, purple. There we go. They are negative 1 point, we'll say 39, comma 0, and also 4.6, we'll go 6.3. 6.3. All right. So what do these mean? Well, the negative 1.39 would mean that the water is essentially on the ground, I guess in theory, right? On the ground, because this would be the vertical height. So no vertical height on the ground. When the horizontal distance is at negative 1.39. Okay, but Linda's holding the hose in her hand. So the water does not hit the ground behind her. No, it doesn't. She's holding it in her hand. So that first one that's a negative value, that does not have any meaning. Now, the second one does mean that at a distance of 4.63 feet, the water lands on the ground again. Um, but in this particular case, she's standing 3 feet from the car. So if that's when the water hit the ground, it would mean that it overshot the car. So I don't know if that makes sense either. The water's not going to land on the ground. It should be landing on the car. So this one's a little bit sneaky. The way that I think we would handle this is you could kind of say it both ways, maybe to cover your bases. You might say something along the lines of, when the water, or you could say the water hits the ground. That would be the zero, right? The water hits the ground at a horizontal distance of 4.63 feet, because that is what it means. It is. But then you might just kind of add to that and say, however, there might not be meaning. Not much anyway. Not much meaning because the water should be, will be hitting the car, not the ground. So that one's kind of sneaky. Um, I think every teacher is different, but I think for the most part, if you were to say, okay, this is what it means it hits the ground at a distance of this. Yes, that is what it means, period. But then sometimes it's nice to acknowledge, okay, even though that's what it means, in this context, it might not have meaning because it's going to be hitting the car. And if it went, 4.63 feet, well, that means I guess you missed the car. So it gets a little bit awkward. So maybe we would caveat it like that. Okay, let's go with that. Part C says, determine the vertex and explain the contextual meaning. Okay, vertex, touchable point. There you go, touch it, done. So the turning point of this parabola is going to be 1.62, let's round it, 1.62, comma, 5.32, if we round it, 5.32. So that's where the vertex is. Now, what does it mean? Well, again, we've got the horizontal distance of the water as well as the vertical height of the water. So the water path reaches its max, don't need an apostrophe. What are we doing, Bishop? Its max height of 5.32 feet at a horizontal distance of 1.62 feet. Yeah, I think that works. So just keeping in mind what those variables stand for, like I said, H is the horizontal path, V is the vertical path, and that'll help us contextualize it. Okay, so for practical, domain, and range. All right, now again, this one is kind of sneaky. Since we are wanting to wash our car, we are standing 3 feet from the car. So in theory, if you want your water to stop when it hits the car, again, you don't want to overshoot the car. You don't necessarily want to go all the way to 4.63 or whatever we had earlier. Yeah, 4.63. You might choose for that reason to stop your domain at 3 feet because she's standing 3 feet from the car and we want the water to hit the car. So a little bit open-ended here. I'll use inequality notation just to kind of show you both ways. I think what's important on an open-ended question like this is you just want to kind of defend your answer. So if I was going to put 0 to 3, I would probably just write down, I'm going to stop at 3 because that's where her car is, and I want to make sure that my water hits the car. So just kind of justify. A lot of times we'll even ask you to justify if it's an open-ended response. And then for practical range, so the output values, the smallest output value is again, I don't think I'm going to go 0. I don't want the water to hit the ground. I want the water to hit the car. So for that reason, I'm going to use my smallest value as when I was holding it in my hand. So the smallest water value is that 3.78. So that's what I'm going to use for my range as my smallest value as 3.78 because that's where it was when it came out of the hose. And then the highest value for the outputs are going to be that maximum of 5.32. So 5.32. And if I use inequalities for this, it would be 3.78 is less than or equal to V or V of H, which is less than or equal to 5.32. Again, I would say just justify this to be sure. Okay, part E, determine the horizontal distances, potentially plural, of when the water reaches a vertical height of 4.7. Okay, so vertical height 4.7, this is an output value. So when you're setting this puppy up, you want the 4.7 to be on the outside of your quadratic model. So what was my quadratic model again? Negative 0.587, negative 0.587 h squared plus, I think it was 1.9. Yep, 1.98 h plus the 3.78. Right? Oh, there's no 8, just 1.9h. 1.9h. Okay, so that's the equation that we're trying to solve. Now, how do you solve it? Well, you go to Desmos, that's how. So we already have our quadratic model in here. Where is she? There she is. And now I just want in Desmos to ask my Desmos, okay, I want the output to be 4.7. So Desmos is a computer, of course. So we have to say output values, y equals, as far as Desmos, outputs are variable y in a generic sense, and we want 4.7. And so it does indeed happen twice, once there and again there. So those are my two answers. So it happens at a horizontal distance of 2.64 feet. And again, at 0 point, oh, I said them out of order. Oh, well, it doesn't matter. At 0.59 feet. Those would be the horizontal distances when the vertical height is 4.7. Part F, write the function in vertex form. Okay, so again, guys, at this point, we know the vertex. It's right there. So if that's your vertex, then that's your horizontal shift and your vertical shift. So we have V of H. Your A value is still your A value, so 0.587. And now here comes my shifting. Horizontal shift, vertex went to the right, so minus 1.62 quantity squared, plus vertical shift, it went up 5.32. Remember, vertex form is essentially your translation form. This is your horizontal shift and your vertical shift for that ordered pair. And then last but not least, part G, write the function in factored form. Okay, again, factored form, guys, they are related to the x-intercepts, and we already have our x-intercepts. So here we go again. V of H equals, I know the A value. It has been the same this whole time. And now h minus the first x-intercept happens to be negative. So it's going to be technically minus a negative. I'm going to shortcut that plus 1.39 as well as h minus the second x-intercept, which was 4.63. So minus 4.63. And that is the same function, but in factored form. Like we did on the last example, guys, you could graph those two answers right here. So y equals, write the equation for your answer to part F. And then down here, y equals, write the equation for your answer to part G. And you can make sure that all three parabolas line up perfectly on top of each other. Okay, that does it for question 4. That one had a little bit of open-endedness to it, so reach out if you have any questions, but overall, hopefully that was helpful. Thank you.